Okay, so this video we're gonna quickly go over what percent error is. So I'm gonna just write down something real quick. So in chemistry, specific chemical reactions have theoretical and experimental yields. There's also specific chemicals, physical properties will be like specific boiling points, melting points, freezing points. And I mean, there's a bunch of different values that you can use for percent error, but we're just going to focus on what exactly the formula means. So I'm going to write that down just so you know it, because it is important. So in chemistry, okay, so there's going to be theoretical and experimental values. So I'm going to write down theoretical or tabulated. Actually, let's go with tabulated. Theoretical is more for something else. So it's not theoretical, it's tabled. My bad. That just means that it's been done in a lab setting at specific conditions and over and over and over, and it always comes out to the same value for an average. Anyway, so the table values from a reference book give you like a guide as to what should be the value you get for a pure substance. Yeah, so that would be like, anyways, so we're going to use that as table value, and then experimental value is what you actually get in an experiment. And it's used to explain different, things in the experiment that don't quite add up, and that's where percent error comes in, and it's able to explain things with math. So you're able to infer from it, is what I mean. So let's do a quick rundown of the formula first, and then I'm going to make an example up so we can go over this. So the formula is the absolute value. Wow, pen's not working. So the absolute value of experimental minus tabled value. And then that is divided by the tabled value. So you do that and you multiply it by 100%, and it gives you your percent error. So let's do an example. We're going to say that compound X has a melting point. Usually it's a range that you're going to notice in a lab setting, but we're just going to do this just theoretically so you can see how it works. So compound X has a melting point of 121 degrees Celsius, and this is the tabled value, so I'm going to put tabled. So the experimental value that you did your little test, and your compound melted at, and it's compound X. Your compound X you observed melting at 117.3 degrees Celsius. So we're going to use the percent error formula to figure out what the error is in your experiment. And you can use this to explain certain things. Like if it's off by a certain amount, you could be like, oh wow, something I did with the procedure is probably wrong, or there's contaminants in my reagents, or whatever. This is more just like a concept that you need to know. You're not going to do a lot of this in this class, but in college you will. But I wanted you to be exposed to it because it is important. So absolute value, we're going to plug in the experimental value, so 117.3 minus 121. So you don't have to write the degrees Celsius here. And as you notice, we did the absolute value because most of the time, like I'm not going to say all the time, because sometimes your melting point will be a little higher, but most of the time you're going to end up with a negative number. So percentages, we don't want a negative, we just want the percent. So you divide that by 121 and multiply it by 100. And that would be how you do your percent error. So you can do absolute value in here, but the way I do it is I do negative and then I put the parentheses. 117.3 minus 121. Wow, my calculator is going crazy. Anyways, let's go and use the other one. I don't know what's going on with that. So alright, let's see if it works. Nope. I don't know what's going on. Anyways, I meant to click this one. So I'm going to do it this way. Where's the negative button on this? Do not see it. I'm going to just use this. So 117.3 minus 121, and then divided by 121. Should have put all this in parentheses. And then multiply that by 100. And our percent error is about 3.06%. Sorry about all the glitches. I don't know what's been going on with my calculator, but that would be your percent error. And that's essentially how you do it. It's not like super complicated or anything like that. It's just plug the numbers into a formula. You just have to realize where to look for your tabled values and be honest about your data, because you're never, almost never going to get a perfect result. It's just almost statistically improbable. But anyways, if you have any questions about this, ask me in class or on Canvas. I'd be more than happy to help you with it. And that's it for this video.